Okay, so today we will be learning the mathematics of neural networks. So you may have heard about it, deep learning, neural networks. I want to clear some doubts. Rather, I want to discuss what is learning, what is deep learning, where does neural network come from. My goal is not to cover a lot. My goal is to cover enough depth so that you can understand neural networks and deep learning when you start learning on your own. Also, I will try to connect linear algebra, calculus to deep learning neural networks and how it fits together and how does it help. To understand all of this and all the concepts that you can see on the screen, we have to first ask the question that what is learning? What is deep learning? Okay. So the first question that we will understand is what is learning, what is deep learning? To remind you, I'll be slow, but you can make me slower by asking questions because your understanding is a top priority here, guys. So what is learning? So let's take the simplest possible data set that we all start with is the linear regression data set. So let's say you have some variable, let's say height, and some variable, let's say weight, and you have a data set like this. Okay. So your goal, so what is the learning goal? What is the framework of learning? So here, understand, we will not be doing in a statistical manner. We will be doing in a different manner. I will not go into that because here we have really intelligent people of statistics out here, so they can ask questions. I can answer their questions later on, but I am keeping it simplistic for school students. Okay. So let's say we have this data set of height and weight, and our goal is to, for a new data set, let's say of a new height, let's say 8 star, we want to predict its corresponding weight. Okay. W star. So 8 star to W star. So what we do is that the first step is to learn. To do this, we have to learn this curve that approximates this. Okay, the function that approximates this. So let's call it f of f. So our goal is to learn f and the function f. So x-axis, y-axis, I hope all of you know about functions. And using that function, we want to predict w star, which is a function of the height 8 star. Okay. The input is 8 star, so you want to get the w star, the expected weight of that corresponding new height that you have not seen in the data set. So this is the entire goal. To make it more rigorous, a bit more mathematically rigorous, let me write it down properly. So you have a data set x1, y1. So x1 is the input. It can be multidimensional, and y1 is the output. So this is not just learning framework. This is something called supervised learning framework. But I'm not going into too much details of that. I want to just tell you the essence of this. So we have this data set x1, x2. This pairs. Okay, these pairs are there. This is the data set. From understanding and dealing with the data set, we assume that this y, the output, the response variable, has some functional relationship with the input x. Okay, understand, note, this f we do not know. We do not know what is this f. Our goal is to find f. So our goal is to find this f such that this f of xi, or rather for all the data set, for all the data points, f of this xi That is, this function of this xi is very, very close to yi. So this is the observed values. This is the predicted. So it's also called y hat, yi hat. So for each of the data points, it should be close. Okay. So to make that happen, what we do is that we build a loss function. So loss function such that between this, the loss function for each data set, for each data point, which tells you that the distance between yi, d is the distance, it can be square, like 2 points in the Euclidean plane, between the y at the yi, that is the observed, and the yi hat, the predicted, which is also f of xi. This should be low for all I. So many people, what they do is they define an overall loss function which says that 1 by n summation of each of the individual loss. For each data point there is a loss. So for each data point there is a prediction error, some loss between the true and the predicted. Okay. So we want that average over all the data points to be less, not just for each individual. You cannot actually do it for each individual, like you can see here, but we want the average over all the loss to be very, very less. Okay, very, very low. We want this loss, this is called the loss, the average loss, or we call it the loss, to be low. So now understand that this f has so many choices, has infinitely many choices. Like a lot of choices. So what we do, it's not physically possible for a computer to search through all of them. So what we do often is we observe the data set, we understand the data set, see its pattern, and then we restrict the functional form, the f, to a certain functional form, an expression. For example, in this case, we will say that f of x is nothing but some wx plus b. Okay. So this is a functional form. This is an expression that we are fixing. Because it's linear, we see that it's kind of linear. That's why. Fixing this form, fixing this expression. Okay. So what we do is that to make it simpler, we fix this expression, this functional form f of x. In this case, let's say wx plus b. There can be many other ways out there. Now observe why is it useful now? It's useful because from the infinite options, we have now finite number of parameters in some sense. So you see that to find this function, we just need to find this w and b. So it's finite number of parameters. This itself has infinite number of options, but the number of finite number of parameters is really a helpful condition. Okay. So what we do is that we have now this finite number of parameters. So now they observe this loss function, this L that we have defined. Our goal is to minimize this so that we can get W and B. Now why we can do that? Because this L is nothing but a function of this function f. So, and this function is nothing but made up of W and B. So this loss is nothing but a function of W and B. The rest of them is all constant and known from before, all the operations. So essentially we are minimizing this loss of this W and B, the parameters which we call it, and out of it we will get the best optimal parameters by minimizing it. For linear regression that we have shown, you will, if you plot, you will see, you will get a curve like this, let's say. And here is where the optimum will be. Okay, so Abir has a question. If we really want the loss to be low, and since there are large number of data set, could we not have interpolate? Yes, 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 absolutely. So you're right. And that's a very good question. Yes, that's where the whole idea of learning framework comes. Often what happens is that if we can do that, that's awesome, but there is something called overfitting. So overfitting means, yes, you can find a function that can go through all of this very, very minutely. Yes, it can happen. But often what happens is that this is not a one-to-one. For the same x, you can get multiple y's. That is one. So there cannot be a single function like that. Even if there is a possible single function, there's something called overfitting. And this fixing the functional form of helps. But I mean, I have to go into learning theory then. Okay. So you remember this keyword called overfitting and what we do to minimize that. Okay. So if you, what you said, f is a function. F is a function. So this, if what you're saying is that this each yi is this yi hat plus some error is the error out there, ei, let's say. You're saying that we can find a function so that this is 0. Okay. So f is a function. But we will see that when we try to make it 0 for one, other will become for others it will become high. Okay. When we are generalizing to a new data set. So that's why we can do it in multiple ways. We make the learning framework in such a way that it doesn't overfit. Okay. Or we use in statistics we use a probability distribution. So this probability distribution naturally takes into the error of the data set. And in deep learning or machine learning, we have a train test framework. Okay, cross-validation framework. So there are multiple frameworks. In computer science, there's a train test framework. In statistics, we use a probability distribution because the probability distribution take into account that there is an error. Okay. So we will not learn about that, but I have a free course. I made a free course on YouTube. You can watch that later on. So this goes into the concept of deep learning, machine learning, which I'm not covering today. Does it make sense, Abhin? I wish I can cover it, but yeah. Yes, you're right. Yes, for unknown data set, because that's the goal. The goal is to reduce the error for an unknown data set. So the goal is to reduce expected loss of the parameters. We want to reduce this. Okay. Now, a good estimate of this is nothing but the average of the current data set, the training data set and test data set we have. So that's why we use this framework. But again, I mean, to learn it, understand it really deeply, I have a YouTube course, free course. See, anyone can go out and watch that. So I'm making this video so that you can. So this is the lesson 0. Okay. Yeah, Tanush. So these are all explained in my videos. I am not going to explain it today because it will go in a totally different topic. Okay. So but I have made free videos out there. You can watch it. I will share with you after the class. So okay, let's see what are the questions. So is the excess parameters? Okay, thank you. Is the excess parameters concept to find the optimal Yeah, so the goal, understand that we are making it simple. To remind you, this data set xi, yi, I from 1 to n. Okay. And there's a functional form like, and I'm stressing on this because this is where neural networks come in. And there's a loss. Okay. There's a loss, and this functional form has some parameters theta. And this loss naturally becomes a parameter, a function of the parameters. So our goal is to minimize this loss so that we get this theta star, the optimum parameters, which gives you the optimum function. Because understand, the functional form is fixed, but the function is not fixed. Like wx plus b is a functional form, but if we fix w to be 1 and b to be 3, then the function is fixed. Do you see the point? So optimum parameters, theta, optimum theta. So this is the entire framework of learning, of supervised learning. Actually, any learning, but yeah, I mean, but this is the idea. I mean, this when it is yi, then it's supervised, but I'm not going into too much of details. It will confuse you. But let's call it a learning framework. This is the entire learning framework. Did you understand this, guys? All of you? Yes. Now, there are multiple questions like how to learn, how to minimize. Okay, that is one important question. That is where learning of deep learning comes out. So in deep learning, so in the term deep learning, there are two ideas. One is the learning framework, which is nothing about this minimizing this loss L theta, and the deep is nothing but the functional form, the F. So the deep comes from the term deep neural networks, and the learning is nothing but how to minimize the loss. So today's discussion is mostly about this functional form deep. Okay, all of you understood this? Let me call out the names. Abir, Arhat, Arjaman, or Arjanil, Arno, Atmodev, Devadrit, Devangshu, Himanesh, Paras, Prantek, Rishav, Pritam, Shoparno, Shayoni, Snigdhojit, Jyoti, Shohom, Shoroshesh, Srijan, Shubhadeep, and Tanush. Any questions from your end? All of you understood this? So a code is nothing but a function. So you can see this functional form has tunable parameters that we do not know. So we are letting the model learn. Previously, code-based is nothing but we have less number of free parameters. Okay, so that's the whole idea of transitioning from a fixed framework to a learning-based framework is where we are trying to use deep learning. Does it make sense? Rather machine learning. So to revise, we have this X. We have a functional form. This functional form has a theta. Just give me a minute. This functional form has a theta, and this gives rise to loss of theta, and also this is related to the y. Sorry. So this functional form gives rise to f of x, the y hat, rather, I should call it y hat, and this gives rise to L theta, and yeah. So this is the graph. So the goal is to minimize this to get this. Minimize this to get optimum this. Once you get optimum this, you get the function, because this functional form, this is the functional form. Okay. Yeah, so whatever questions you're asking, these are computer science database management questions. How the data is saved. It's saved in the computer memory. Okay. So those are engineering, computer engineering, architecture, and computer science questions. Computer science in the sense that how data is stored, that's a different data structures and algorithms, that kind of questions. But here we are understanding that how to, given a data set, find the function that such that this f of xi is close to this yi, and using that to predict for an unknown x star that was not in the data set, so that it is close to y star. The f of x is close to y star. So this is the whole idea of learning framework. We are trying to learn. Does it make sense, guys? Questions? Any questions from other students? Feel free to ask
So
questions.
is
Yes, go ahead.
there a possibility that we could go ahead with any model other than linear if it fits? And if it does actually fit that, how do I eyeball it exactly to figure out what pattern it will figure?
Sorry, can you come again with the question? Sorry, my volume was reduced, so yeah.
So what I'm essentially saying is, at the beginning, you said that we could kind of eyeball the data and figure out what pattern it follows.
Yes.
So, other than linear, how do we understand if the other forms are varied or not?
Very good. Very good question. And that's what that was the next part of the discussion. But that is the jumping board for the next part of the discussion. So yes, we cannot do that. And that's why the deep learning comes up. Okay. So neural networks, so I will answer this question over the next some time, as we gradually move on. So what we are learning today is that is this F format. So this neural network that you can see, these neural networks are a very special kind of F, a very special kind of the functional form. So neural networks are very special. Deep neural networks and neural networks. So neural networks and so neural networks. So the opposite of neural networks are shallow and deep. And deep neural networks, the opposite of the word deep is shallow. So shallow and deep, both neural networks are special. Okay, are very, very special. Special in the sense that I define two ways to be special. One is made up of very simple functional forms, simple functions.
So what do you classify to be simple functions?
Yeah. So plus, addition, multiplication, um, exponential, division, simple functions like linear functions. Yeah, I mean mostly linear functions and simple non-linearity. So what do I mean by that is linear plus simple non-linearity.
Okay, sir.
Sir, give example which function will not work. Which type of function?
Let's say log of e to the power, log of tan of h into x to the power 7 minus a sine of 5x minus 3 whole to the power cos of 3 minus. I mean, yes, sine is not a simple function. Okay. So simple nonlinearity. So what I mean is that, so we will define it carefully. What I mean is that, what I mean by that, it's essentially a sequence of linear, that means wx plus b plus nonlinear, simple nonlinear, like you will see like functions like this, ReLU or logistic function, simple functions like here ReLU is max of 0 comma x, it's piecewise linear. Logistic is, let's say, e to the power x by 1 plus e to the power x, like this. Okay, simple functions. Yeah, so it's a sequence of simple linear and a bit of nonlinearity. That's what I small bit of nonlinearity. So it's mostly made up of linear functions, like really, really linear functions, wx plus b. Okay, this wx and b can be matrices too, and this can approximate any function. So for example, Taylor series, okay? Taylor series can approximate any good function, right? Probably you know about Taylor series, right? But Taylor series is also made up of high degree polynomial. Okay, those are highly nonlinear, and they're not just one linear and others nonlinear, right? So it's good, but we want simple linearity because computers can, because computers can compute linearity very easily. That's why, because you can do it in a parallel manner. That's why GPUs are useful. So that's why this Taylor series is an example of, it can approximate any function, but it's not nonlinear. It's not simple function made up of simple functions, very simple functions. Does it make sense, guys? All of you? Yes.
Yes, sir.
Yeah. So in fact, we will see that this universal approximation theorem is telling you that yes, you can use any neural network to approximate any function, good function, continuous smooth function, like, let's say. So this is why neural networks are really useful. But there, as I said, Taylor series was there. Why it was not used before? Because it is not simple. It's not made up of simple functions. Okay, it's not made up of simple functions. That's why. Okay, which neural network solved, and it worked out actually. And another thing that I think is important, but that is not relatively simple, is the fact of it can. Let's not go into that. Yeah. Anyways, okay. So now, natural question is that what are neural networks then? So we address the first question, that what is learning and what is deep learning. So the deep learning means deep neural networks and the learning framework that is there. Okay. So next question comes up, that what is neural networks and how, the next question, neural networks independent of deep learning. We want to understand that. So neural networks are, so what are neural networks? Okay, let's Abhi ask a question, if we could. Degree zero function is a constant function, right? And a constant function is also a linear function. Okay, so then probably I forgot the definition of degree zero. What is ax square? Is the x square in the denominator, Abir? Oh, I see your point. You mean a rational function. It's not a degree zero function, because degree is defined for a polynomial. Okay. So you are saying, yeah, so I mean, yes, it can also approximate a degree. I mean, yes, rational function. Yes, but rational functions have discontinuities, right? So that may be an issue, because it's not a it's usually not discontinuous. But yeah, it can also do discontinuous functions. That's true. That's true. Neural networks can also approximate discontinuous functions. Yes. And I will show you an example. Simple. Yes. Okay. Any more questions? Yes, you can use many approximations, but again, this deep neural networks, this deep learning framework came out. So whatever you are saying, those are 1 degree or maybe simple 1 degree form. Taylor series here is 1 degree, but there are also multi-degree extensions. But these are all good for tabular data. But this neural networks came up for raw data. Raw data means images, audios, all these things. And you need to input the entire data, not transform data. In statistics, so I have a statistics background, right? Because I learned from ISI, bachelor's and master's, and we only worked with tabular data. So that thought process was broken completely when I went to computer science and electrical engineering department. There, the goal is to how to build functions or processes or algorithms for raw data. Like the input will be an image, no transformed variable of the image, right? In statistics, that's not the case. We make it into tabular form so that its input is a matrix, and then we do it. It is good. But what this all technology is based on raw data. So the raw data manipulation, raw data functional form, it needs a different approach, and that's why neural networks are so widely useful and effective. Does it make sense? Yes. So from that point of view, because this is not usually, I mean, this was not taught to me at ISI, okay? This is what I have learned at Penn State. And I don't think, I mean, it was not necessary to be taught at ISI. But what I'm mentioning is that there's a different point of view you should also think about. Okay, because you only know about tabular data format in statistics. All statistics people know about that. But other people work in a different way. And that's where the computer science point of view came, because those are high dimensional data set, like multi-dimensional image of a CT scan. I work with brain images. A CT scan is this. So it's 2 to the power 9 times 2 to the power 9. So it's 2 to the power 18. 2 to the power 18 dimensional vector is coming to me. If the input is 2 to the power 18 dimensional vector. So you see that there's a lot of correlation between different vectors. And that needs more understanding about the data set. So as someone asked, I forgot his name. He asked that how did the neural networks come in? Because not only they are good approximators, for example, Jan LeCun, who developed the convolutional neural network, he used the brain geometry, like how we perceive vision, into the format of how we perceive vision into this linear, nonlinear, into neural networks, using these linear, nonlinear layers only. So it's a totally different kind of approach. For example, we see the data set there, but here we build based on how our brain sees, how building a model for the data set, for a specific data set. We just do not use a linear layer we do not use just any neural network. We use specific neural networks for different data set. There, the main goal is raw data, not transformed good data. This is very important. This is a very different way of thinking, okay? So I'm telling all of you, including the students at ISI right now. Okay. So, all good, guys? Can I move on to the next idea? Next topic?
Yes, sir.
Okay. Okay. Now, what are neural networks independent of deep learning? So neural networks are nothing but functions. So this is a tagline I wanted to arrive at. Neural networks are just functions. Simple functions. There's an input and there's an output. But a special type of function. A special type of function. Okay, what kind of special type of functions? So this has something to do with electrical engineering, how circuits, electrical engineering, and mathematical logic. For example, let's take the simplest possible. So we will now investigate this function. Okay, we will now investigate this function only. Okay, understand this very carefully. Investigate this specific function called neural network, but I will not define it directly. I will define by some examples. So let's solve this simple problem. So let's say you have a line 2x plus 3. Okay, like this. I'm so sorry. 3y. is equal to 1. Okay. No bijectivity as of now. Let's just focus on this next part of idea. Okay, guys. So let's say we have this function, this line. Now your goal is how to build an algorithm to detect whether a point is on this side or not, on the right side, to see if a point is on the green side of the line. Any idea? Any idea, guys?
Well, for starters, you could just randomly pick a point. Like you could just randomly pick a point, no? And then if you say pick a point which is by definition, for example, the origin, which we know over here is on the right hand side. So
Right.
now if I just substitute the point which I have picked, cherry picked, into the line equation of the line, and then again just substitute the origins equation, then I can compare the positions of both the points with respect to one another and the line. And if it is positive, then I will get that they lie on the same side, that is on the red side. And if they're negative, then I will get it lie in the opposite side. And since the origin is on the red hand side, it will lie on the green hand side.
Will it not be positive and negative? I mean, you're close. So what Abir is saying is that first put 0 and 0. Okay. So let's say this is a line called x comma y. So let's put L of 0 comma 0. So we get -1, right? So that means everything on this line is -1. I mean, less than 0. So what he's saying is that L of x comma y on red side is always less than 0. Okay. The line itself, so here it's all 0. The red is 0. The L of x comma y on green side is always greater than 0. Okay. You can put any, so this is a half comma 2. You can take a 1 comma 1. It's not, this line doesn't follow, so you can take 1 comma 1 here, and you can see 1 comma 1 is on the green side and it's always positive, right? So what is the algorithm? The algorithm is this, that you have input x comma y, two input x and y, two variables x and y, and you check the value of 2x plus 3y minus 1, and then you have a function like this, which is 1 if it is greater than 0. It's called a step function. Step function is saying, so okay, let's make it simple. So you have x comma y. You first check what is the value of this, and then you check if you make it 1 if it's greater than 0, 0 if it's less than or equal to 0. Okay, if the value. And in this case, if you put 1 comma 1, you get 2 plus 3, 4. Since it's greater than 1, it's get 1. If you take 0 comma 0, you get -1. Since it's less than 0, then it's 0. So the algorithm is this, right? All of you understood this? Yes or no?
It's kind of like a signum function thing, right?
Yes, absolutely. But all of you understood this? The algorithm, did you understand?
Yes.
Any questions? Any questions, guys? Okay. Super. So now you can represent this like a function like this. So you make it, you multiply 2 here, you multiply 3 here, and you have another one. This is called a bias. You multiply -1 here, and you add all of them up. Okay, so what you get is 2x plus 3y minus 1, and then you have another activation function, nonlinear layer, which says whether it's 1 or 0. This is the final output. So this is a step function. This function is nothing but g of x is 1 if x is less than x is greater than 0, 0 otherwise. And then, so this is a function, right? This is the algorithm, right? An algorithm is nothing but a function. Yes or no, guys?
Yes, sir.
Very good. So you can see this is actually a neural network. So this is a form of a neural network. Okay. Now let's take another interesting example. Why the neural networks? Again, neural network is defined as a sequence of linear and simple nonlinear. By simple nonlinear layers, I mean is here is the simple nonlinear layer, there is step function gx. So in this talk, we will only focus on this step function only, okay? Not other functions. There are other nonlinear functions. You can watch my entire YouTube course to understand what are different kind of nonlinear functions. Okay, so this is one example. Let's solve another type of problem. So instead of this single line now, what we will do is that instead of a single line, we will now have two lines. This and this. Okay. And we want to only consider the region here, the cone structure. So the problem is, build a neural network or build an algorithm or function which gives 1 if x comma y point, this is x, this is y, is in yellow region and 0 otherwise. This is the function you need to build. So what is on your mind, guys? Very quick, because I don't have much time left.
So we do that same thing which we had done for that single line twice this time.
Okay, so let's see. So you are saying here is x comma y. So let's call this line 2x plus 3y minus 1 is equal to 0. And this line is, let's say, x is positive, y is negative. Let's say the 2x will be the same. So 2x minus 3y is equal to minus 1 is equal to 0. Okay, so let's say these are the two lines. And so you are saying that we will build something like this. So there is 1 here. So let's build this summation of so in x we will get 2, for y we will get 3, and for 1 we will get minus 1 for this red line. So this is the red one. So let's make it red. For the green line, we'll have another one. In this case, it will be 2 again for 2, this minus 3 for y, and minus 1 again. So we'll get another summation. And we can have another nonlinear layer here, the step function, which will say whether, yeah. So you're saying this, right? But what after this?
And then you just combine both of them through an AND gate.
Okay, great. So we can combine then with the AND gate, but how do you? Great. So what he's saying, very good. So what he's saying, who is this? What is the name of the student?
So Abir Mukherjee.
So yeah, what Abid is saying is that so here's an issue, a bit of an issue in the sense that what Abid is saying is see which on which side it is 0. Here you can see that. So what Abid is saying is this. For the red line, we already know. So let's predict this region as 1. Okay, let's predict this region as 1. And for the green line, let's predict not the 0, this region as 1. And then have an AND operation, and mathematical operation. So you have to be a bit careful. So let's understand what we mean here. So what we mean here is for x, y, we first predict this 2x, 3y, and 1. There's an AND, there's a step function. So this is the nonlinearity, and together this is the linearity. Okay. And this tells you, this gives 1 if in red. Understand this. If it's red region, it gives 1. How? We have done it here. I mean, here it's green, but yeah. Now we will do the green part. The green part is a bit tricky. Because understand the green part, the 0, 0 is here. So if this line is 2x minus 3y minus 1 is equal to 0. Here you can see that for 0, 0 it's negative again. But yes, it's the same function, but you have to do it once. Here it is on the side of 0. Here the red is on the opposite side of 0. Okay. So here you have to make sure that if you want to make it 1, you have to make sure that 2x minus 3y minus 1, this should be negative. In this case, 2x minus 3y, 2x plus 3y minus 1 should be positive here. Here it should be negative, the functional form. So here there's another one. So let's make it like this. Here 2x minus 3y, remember, minus 1. We again add it. Okay. This is 0, but we want to make it 1. So what we do? We make it negative of everything. So we take the negative of everything. So now it will become positive. Now it is 1 if green. Did all of you understand this? Did all of you understand this? So we made 1 for both red and green region. But remember, we did a change here. We multiplied minus with each one of the coefficients, so that because we want it to be negative, that's why. Yes, yeah, I mean, what I'm doing is this minus is nothing but the not logic. Okay, that is also, but we understand we want to have a linear, non-linear, this kind of step. So that's what we want to understand. This is very important. So all of you good with this, guys?
Add the results, right?
Time? Yes.
We could just add the results to get the combination, right? It's 2 if it's lying in both of the regions, 1 if it's lying in either one of the regions, and 0 if none.
Yes, but we want to have a linear, non-linear format. And the output should be 1. So yeah, you're right, absolutely.
Multiply.
Yes, so you're right. We will absolutely do that. We can multiply, we can add, we will add actually. And you're right. So let's see what's happening. And so what we want. So we have x, and so here the input is 1, 1 or 0, 0. Like either 4 inputs are there, 0, 1, 0, 1. So here 1, 1, 1, 0, 0, 1, 0, 0. So it's an AND operation, X and Y. So what we want is for 1 and 1, we want 1. For 1 and 0, we want 0, 0, and 0, right? We only want 1 when it's both happening, right? So yes, you can say we can multiply for sure, but multiplication is not a linear operation. You see the point? So that's an issue. So we want simple linear operation. Multiplication is hard. Linear is easier. Multiplication means the input multiplication. Here we are multiplying the input with some constants and adding it, like it happens in vector spaces or linear spaces. But we never multiply two numbers in linear spaces. Do you see the point, guys? But essentially we cannot multiply two inputs. That's the rule of thumb. We want to use linear. We can only add inputs. We can never multiply inputs. That's what I mean by linear. Okay. We can multiply the inputs by constants, but we cannot add and multiply inputs. So what we do? So let's take this. So here, what we will do is simple. So we will add another 1 here. And out of this, what we will do is we will have one single neuron output. Okay. So with this output, we will multiply 1. So what we will do to test this, what we will do, we will make x plus y. So we will get 2, 1, 1, 0. Now we can have a step function because we want output to be 0, 1. So for this, what we do is that we want to make it positive, else it will be negative. So we subtract minus 2.5 from all of them. Sorry, minus 1.5. So this becomes 0.5, but all other becomes negative. And then we add a step function g here. So when we add a step function g here, when we add a step function here, we get 1, 0, 0, 0. Makes sense, guys? We add 2, subtract my 1.5. Now we are making it linear. See, we are multiplying 1, 1 each individual. And with this 1, we get minus 1.5 multiplication. So essentially we get, if this is x, this is y, x plus y minus 1.5. And then we will add a nonlinear layer here. And then it will be output will be 1 and 0. Does it make sense, guys?
Yes, sir.
All of you?
Yes, sir.
So there's a homework question for you guys. So you can see we have built an AND function here. So in fact, you can build any logic function. One is a XOR. So this is a nonlinear. So think about it. So I will give you 2 homeworks. In fact, you can also solve this. You can find the answer online. One is a XOR and one is a triangle. For the XOR, the whole idea is the data set. So the positive data set. So your goal is to find this region. Build a neural network. So your goal is to find an algorithm f of x, such a neural network, f such that it's 1 if red, 0 if green. You can see it's a non-linear layer. You cannot use linear layers to do it. So the basic idea is you can understand that you have to have this line and this line, have an AND here, have another AND here, and then an OR. Do you see the point? Have an AND here, have an AND here. So there are 2 lines here. So one and here, one and here, and then an OR. Do you see, guys? So your goal is to build a neural network for this, and it's not easy. Okay, it's not easy. So, and you will need a few layers. Here we just need one layer, but there you need at least 2 layers. So the more the complicated function, the more the number of layers you need. Okay. Now also you do it for a triangle. So now you're given a triangle. Instead of 2 lines, you're given a triangle. Your goal is to find whether a point is inside a triangle or outside a triangle. Here we have found, so your goal is to find a point whether it's inside a triangle or outside a triangle. So 1, if inside a triangle, and green it's outside. Okay. I have solved this problem for you guys, and I have been motivated this. I have made a notes for you guys. You can check this out, and you will get a function like this. And it's you need some layers. Probably you can do it in 1 layer only. You don't need 2 layers. So it's a 3 AND functions. Okay, 3 AND function. Yeah, you don't need 2 layers. But for the XOR, because it's made of linear, you don't need 2 functions. But in this case, you need 2 layers. Because there are 2 ANDs, you can build with 1 layer and 1 OR with another layer. Make sense, guys? Do you understand? So this
Yes,
is,
sir.
so what I'm trying to make you understand is neural networks are a very special type of functions. They are not, they are just functions. You have to look at them as functions, not like something different. So deep learning consists of deep neural networks, which are functions, and a learning, and you have to separately learn them differently. So neural networks have a mathematical logic understanding. In my Penn State, when I was taught in this way, I didn't know about this. I have to learn all these things by taking undergraduate classes in my PhD to learn and understand these things. And in my final examinations, they gave a beautiful question. The professor's name was Davis Miller. His name is David Miller. He gave us this problem. You have a tetrahedron in 3D. Okay, tetrahedron. The goal is to find a neural network, build a neural network that gives 1 if the point is inside a tetrahedron and 0 if it's outside. So the input in this case is x, y, z. In that case, it's a plane. You see different planes. So you see, neural networks are nothing but this interesting function approximators. Okay.
Sir,
Yes.
so if instead of having, say, a linear function whose region we have to find, can we actually like generalize this idea to a higher degree curve, say a 2-degree curve?
Yes, of course, but then it will be hard for the computer. Remember that rule number 1, you have to make it using simple linear and nonlinear layers. Because when you make it higher nonlinear, the computers will not work optimally.
Oh,
Because,
okay.
yeah, so that's the whole idea. Do you see the point? Otherwise, we would have only used Taylor series, right?
Yes, sir.
Because what you're saying is nothing but Taylor series idea. Yes, we can use that, but the computers only learn well with linearity because it can do parallel computation in linear layers.
No,
Okay.
like I wasn't really saying Taylor series. What I was trying to say is that if I have a circle, say, then I can just, for the triangle part, I could have just plotted out its in circle and its circumcircle, and then I could have found out just the region in between those two, and and then only the points which are inside the circumcircle as well as the incircle, I'll give them a 1, and it will approximately give me, and the lines which are in the circumcircle but they're outside of the sequence, I will give them a 0. So like
Yes, you're right. Yes, yes, there are many ways to do it, but you can only use linear layers.
yeah, that is why I asked it. Okay, sir.
Yeah, I mean, it's just simple. Like here we use 2 lines, you have to use 3 lines. So it will be something like this, another line and another AND function. That's it.
Yes, sir.
Yeah, but you can do it in many ways. My goal is to make you understand that neural networks are actually also doing mathematical logic internally. So to do this, I did a simple experiment. Okay. I did the same experiment. So a simple experiment is that I generated data from a circle. So inside, you can see inside the circle it's red, outside the circle the yellow, this curve is a circle, this white curve is a circle. So inside the circle it's red, outside the circle it's blue. So I built a this one layer neural network. Okay, just a one layer neural network to predict, to find this decision boundary. Okay, so how I did this, I generated a data set like this and I wanted to learn the boundary. And the neurons, there are 3 neurons. Okay, so input was x comma y, and there are 3 neurons, and there was also a bias like this. And you can understand that each of these neurons is nothing but a line. Each of them is nothing but a line. Ax plus by plus c, right? So you can see that it found out 3 lines. And the closest it could do is, the closest decision boundary it could make with 3 lines are this triangle, right, of the closed structure. And it was a one layer, just like this one. It was one layer. This is a layer. It's called a layer. And then it implemented, and you can actually understand from these neurons the value of the neurons. So essentially, this is nothing but, you can actually see that this is, you can actually understand why this is a AND function. You can prove this is an AND function. So try to study this. I will post this notes on LinkedIn. You can go ahead and study from there. But this is an AND function. You can find it out. Okay, but this is beautiful. So these neural networks are interpretable in some sense. They're not always black box. So what I did is that also I increased that 3 to 10. Now it is a, although it's a curve because I have a nonlinear curve there, but essentially it's a decahedron. A polygon with 10 sides. Okay, so not decahedron, decagon. Yeah, decagon. So yes, so each neuron acts as a line here in this case. And after that, it's doing an AND operation to find the region inside. And you can increase this and you can find a general polygon out there. Does it make sense, guys? So my goal, the message I want to pass to you, or rather tell you before I end this, is this, that neural networks are just functions. And deep neural networks, by this approximation theorem, so we have learned this simple neural networks. We have gave Zod problem as a homework. I also discussed that problem in my YouTube video. Please check it out. I gave a simple 2D example of the circle. This deep neural networks are nothing but and I will do this both, is nothing but this multiple layers and nonlinearity, like this linear layer and a nonlinear activation layer, linear layer and a nonlinear activation layer, sequentially. And you can prove mathematically this can actually approximate any function. Okay, these are mathematical theorem. So to do that, you need calculus, and to do this linear nonlinear layer, you need matrix algebra. And this is the fundamental, this is the structure of neural networks that is used in each and every applications of AI you see today. Okay, guys, just that for different data set, the structure has changed. Transformers have been used for language. Convolution has been used for image, because these are specific functions. Just like looking at the data set, we saw that, okay, we need a linear function. Similarly, looking at the image data set and how human beings see, visualize, we used convolution. Looking at how language works, we use transformers. So building blocks of the neural networks change, but the structure of linear, nonlinear, linear, nonlinear remains the same. And the building block structure change based on how the data set is. Okay, and this is what is deep neural network for you guys. The other part is learning, which you can find it in my YouTube channel, and I will share the YouTube video with you guys. Any questions? Yes.
So where do we get those typed notes?
I will. They're not. I will share the link with you guys here. That is posted on LinkedIn. I will share with you. Just give me a minute. Let me first share the. I will share this also with Arnab, in case you lose it. So let me share this with you. Yeah, you can reach out to me on LinkedIn. Just say that. Yeah, so this is the lesson. Okay, guys. I have already built a lesson. This will be given as lesson 0. Okay, before the introduction to neural networks. Yes. So I will share this crash course with you. This is a free one. You can check it anytime. Let me share it here. So this is the course. I will give my LinkedIn profile to and the LinkedIn notes. So I will post this LinkedIn notes that you see on the screen today. So rather the ones I taught now. So you can, but the LinkedIn notes I will post today. But the LinkedIn notes I have the notes I shared, the triangle notes, I will share it right now in the text box. Just bear with me. Wait. Yeah, here is it. So let me paste it here. And the LinkedIn profile is this. Okay, I pasted it here. I will also share this with Arnab so that he can give it to you. Okay. Any questions, guys? Any questions from your end? I'll stop sharing.
Sir,